For this question, we see we've got some graphs, so we'll start out analyzing the graphs before we read the question. And we'll start out with our Oyxerga. So Oyxirga. So the origin, all of them are at 0, 0, so we're good there. The y-axis for all of them is the acceleration. The x-axis for all of them is time. Now the intercepts. So the intercepts would mean at time 0, so the y-intercept at time 0, it's the acceleration, so it's the a0. And the x-intercept would be the time at which the acceleration equals 0. Now, what we can read from the graph are the axes, acceleration and time. The gradient is dividing the axes, so delta A over delta T, which is the definition of jerk. In the area, A times delta T is the change in velocity. So the acceleration, the area of the acceleration time graph is the change in velocity. So now we could ask ourselves, what is going on with the acceleration? So the acceleration shows it increasing. The second one shows it increasing. The third one and the fourth one show it decreasing over time. So A and B are clearly different from C and D in terms of overall. So now let's take a look at the question. A ball initially at rest, so that means V0 equals 0, is dropped from the air at a great height. Air resistance is not negligible, so air resistance then matters. It matters. And so something dropped is going to start out with an acceleration equal to 10, and if there's air resistance, if it goes long enough, the acceleration will end up being 0 at terminal velocity, which shows the variation in time of the acceleration of the ball. So we can see right away, we've already identified that in the beginning, acceleration is 10. And if we look at the first choice, it says the acceleration is 0. Second choice, acceleration is 0. So simply knowing that the acceleration is not equal to 0 in the beginning gets us down to 50-50. So we look at both of choices C and D, and they show us starting at what could be a value of 10. It shows us them both going to 0. So the question is, does the acceleration go to 0 at a constant rate or at a gradual rate? Now, if we look at the actual slopes here, the acceleration is changing a lot there, and then less, and then less. And so this shows a gradual rate. It's actually eventually asymptotically, it approaches zero slowly, whereas this one is it just goes at a constant rate. And of course, we know that it's actually at a gradual rate, so choice C.